Hello everyone, I am Harsh Patel along with Krina Suma and Nitesh Mishra from Group 15. We are going to give you a presentation on the biometric systems, its vulnerabilities and defenses.
And these are the topics that we are going to cover in this presentation.
So first, we will discuss about what is biometrics. So basically, it is an authentication process that is solely dependent on physical characteristics of user as it's unique and measurable. The whole process is highly dependent on the process of matching live template and the template that is stored in the database, where the result of a acceptance rate and rejection rate depends on the similarity score of both the templates. The acquisition environment or user interaction with the acquisition device may cause changes in the biometric samples. This results in similarity or dissimilarity between users. Fixing the biometric data's level of variability will prevent the system from becoming vulnerable to intrusion and security breaches by accepting too many authorized users or rejecting too many unauthorized users. There are several methods that are used to attack biometric systems that includes acquisition of facial images or latent fingerprints, imitation of behavioral identity, reproduction of signature or voices, replay or false data injection. Now let's see what the threat vectors on a vulnerable biometric systems are. So the nature of biometric systems can be helpful to analyze the type of attack that can be conducted against a system, and that helps to determine whether the system can be made vulnerability resistant or not. So these are the threat vectors on a vulnerable biometric system. The first one is denial of service. The denial of service prevents access of a privileged user to the system. The second one is circumvention. The term circumvention relates to the misrepresentation of access privileges and unauthorized people getting access. The third one is repudiation. Threats involving denial of access by a malicious user are referred to as a repudiation. And the last one is collusion. Threats of collusion refers to instances in which an attacker is assisted by a privileged user, such as an administrator, or in which a legitimate user is compl- compelled to assist the attackers. Now, there are some threats on a vulnerable system that might harm the system in a different ways. That includes faults, failures, and security attacks. We will further discuss all of them in details. So faults can be categorized depending on whether it's internal, like like a development faults, external that can be happen due to interaction with various environments, or physical that affect the hardware component. The development faults include software aging, software space fragmentation, and data corruption. There are also some human-made faults like the DOS attack and accessing secure information, improper modification of software's lifecycle, disruption of any services, and many other. Faults can be malicious or non-malicious, depends on the results. Where non-malicious faults are the consequences of mistakes such as accidental acts that manager and user are unaware of, or deliberate faults that are the result of poor decisions. Malicious faults have the goals of harming the systems. For example, the Trojan horse, Trojan doors, logic bombs, virus, worms, and many others. Now let's talk about failures. Failures occurs due to improper implementation of system functions. For example, service failures, development failures, and security failures. These type of failures can occur due to different type of reasons. The service failure does occur due to the service fails to provide intended results as compared to supplied results. The development failures occur uh, when the program gets terminated without providing desired result, which can be due to the inadequate design of workflow. And the security failure will take place when the failure of service is quite severe than accepted level, like high attribute level of efficiency, integrity, and confidentiality. And the third threat that is a security attack on a biometric system is a man-made threat. It can be done by adversary either by targeting machine itself or the person who is operating the system. As shown in figure, there are few types of these attacks which can be categorized into user level attacks, its components or attributes, attack on biometric templates, and lastly, attack on the person who is operating that system.
Thank you so much, Harsh. Now we will talk about user level attacks. So, these attacks occur mainly because of the fake biometric samples, the biometric devices, or any system for the identity verification. So, fake biometric sample is a user level attack which is shown in the last figure. So these are commonly used biometrics such as face, iris recognition, fingerprint or voice recognition are not secret because whenever people go to any places, they leave their physical print such as finger or their fingers on everything they touch. Uh, like their iris pattern can be observed anywhere they look. The faces are visible. So these biometric prints are public. So it is very good opportunity for the intruders to leave these prints and copy them as real. So these attacks are common on the systems that do not have sufficient security measures to difference between fake and genuine biometric print, and thus this is decisive by intruders. Now I will talk about the attacks on the components and their interfaces. The components of a biometric system that are highly vulnerable to attacks, which includes the quality checker, feature extractor, template database, and matcher. And the example of these attacks includes from type 2 to 9, which are reply attacks, false data image, override feature extractor, feature vector attack, override matcher attack, override decision attack, modify templates. So these are attacks. These are the attacks apply on these components of the biometric system. So the interface of the different components are attacked with an aim to hide the intermediate code of a component and then intercept their information and then it reach to the next component. For example, the code generated at the feature extractor can be intercepted by the malicious program like logic bomb, trojan horse or any other set of feature as desired by an adversary is produced. Now we will talk about attacks on a biometric template. Templates are a most important part of biometric system. It is a key sample of a biometric identity which can be collected from the enrolled population for that authentication. The biometric identity of an individual is not digital certificate that can be issued by a third party when the templates are stolen from the database. So we can take an example. That iris-based recognition system authenticates the individuals using their iris codes. And iris codes are unique for every individual, even for the identical twin or even for the both eyes. So if someone steals the template of a iris code, then the only possibility left to the user is to use the iris of the other eye, nothing else. A biometric system is also vulnerable to various attacks that exploit the administrative loopholes. The administrative bench that is responsible for efficient functioning of a biometric system that can be targeted by an adversary. Now we will talk about the attack on a supervisory bench. So the attack of type 10, which is attack on a man supervising the system, target the administrative bench or the group of persons that are responsible for safe and secure functioning of the system. If a system is functioning under inadequate administrative measure, then it is vulnerable and easy to crack. And then for the any adversarial attack. So the users can be frightened and forced by the adversary to provide their biometric sample. An authority can itself do malfunctioning such as modify the system parameters or they make them available to adversaries for incursion by a hidden agreement between them. One of the harmful attack of this attack is being on the privacy of an individual. Biometric system defenses. Ideally, there is no electronic authentication system is completely secured and no single protection mechanism is sufficient to protect the system. But the sensible and practical measures that can effectively reduce the risk of security threat to an acceptable level. There are numbers of proof defenses techniques in practice that are effectively guard or reduce the risk of security threats and vulnerabilities of the biometric system. So, the security techniques of a generic biometric system that are effective against the system attacks can be grouped into two classes. First one is vitality detection technique, and another one is biometric template protection technique. First one is vitality detection technique. So, it ensures that the presented biometric belong to a live individual who was originally enrolled in the system and not just any live person with or without fake biometric. The objective of vitality detection technique is an actual measurement of a biometric sample that is being taken from a legitimate and live individual who is indeed present at the time of enrollment. So, the successful functionality of a vitality detection technique essentially improves the reliability of a biometric system because it ensures that no non-live sample is accepted. So, this existing technique can be broadly be divided into two classes. First one is hardware based technique and another one is software based technique. So what is hardware based and software based technique? In vitality detection technique. So hardware based technique detect the vitality sign from the available biometric sample during the acquisition stage. So this technique used to measure the vitality sign from a fingertip placed on the sensor includes the temperature, honor, pulse oximetry, blood flow and spectrum information. Now software based technique. So these techniques are used to extract the any one peculiarity of a live science from a single sample or from multiple sample like it's called a static technique or a dynamic technique as well that differ from artificial reproduction. There is a one more technique is available into the vitality detection that is multimodal technique. So the measurement of vitality detection can be enhanced by acquiring multimodal data for identity verification. It has been shown that inclusion of more than one biometric information complementing each other for a robust authentication. So, Chetty and Wagner have proposed a system that combines the face information with the voice information. The combined system of face and voice can be able to verify the vitality of biometric sample through the synchronization between movements of lips and the voice prints recorded in the system. So this combination of two biometric sample is called a multimodal technique. Now we will talk about the performance evolutions of vitality detection technique. Despite a variety of vitality detection techniques are known, but the problem of assuring the vitality from biometric sample is practically harder. Independent measure of vitality detection shows that the matching differences of distribution between live and fake sample is smaller than the matching differences of distributions between genuine and imposter sample. Therefore, spoofing the system in absence of vitality detection technique causes a false match without the doing the adversary effect. So yes, this is the performance evolutions of vitality detection technique. So now my another group mate will carry forward this presentation with the another technique. Thank you so much.
Now let's start with biometric template protection. To effectively guard against biometric system vulnerabilities, it is important to protect the biometric templates stored in the database. Biometric templates are the key documents used for establishing authenticity of the individuals. Therefore, templates are essentially kept secure and protected from the reach of intruders. If the security of database templates is breached, then security of the system is compromised adversely. Ideally, a template protection scheme should satisfy a number of requirements. First, the stored template should not exhibit the original sample that can be replayed to the system. It should be computationally harder for an adversary to guess and revoke the original sample or any close replica from the stored data. Secondly, template database must be anonymous. That is, the biometric data of an individual can be used as multiple and varied identifiers for different applications without correlating with one another. For example, if the biometric sample of an individual is compromised, then a fresh and new sample can be generated from the same biometric identity of that individual. Finally, the template protection mechanism should not lead any significant degradation in matching performance, that is, increase of EER of the biometric system. A number of hardware and software based techniques have been proposed to protect the stored template present in the system. Hardware based techniques use smart cards or standalone biometric system on devices. An example of such solution is commercial product called Preverus Plus ID. The main limitation of the hardware-based techniques are that they are expensive and inconvenient, mainly because a user has to carry them always and are prone to being lost. In the software-based techniques, the biometric features are integrated with some external key and the resultant data is stored in the system database instead of the original biometric template. The software-based template protection techniques include feature transformation and biometric cryptosystems. Former technique transforms the biometric features of an individual sample using a user-specific key such that the matching is being performed in the transferred domain. Later technique associates a cryptographic key with the biometric template of an individual to generate biometrically encrypted data which does not reveal any information about the original template or the cryptographic key. Now let us talk about the template transformation. Consider f is a transformation function applied to a biometric template T which generates its transformed information fkt, where k is a user-specific key. Let q be a biometric query, then using the transformation function f, its transformed information fkq is generated. Let M be a matching algorithm that performs matching between biometric sample T and Q and returns a match score. A matching decision, either accept 1 or reject 0, can be taken on the basis of decision threshold lambda. That is, decision is equals to accept if M of fkt and fkq is greater than equal to lambda. Otherwise, the decision is rejected. Figure A describes the Plus ID, which is a portable device with a built-in fingerprint sensor, and the figure B describes schematic diagram of template transformation technique used for template protection in biometric security system. The schematic diagram describes the choice of a function f should be non-invertible because the non-invertible transform is strictly a one-way function. It means that for a given transformed information fkt with an user's key k, the original template t should not be revoked in a reasonable amount of time. Consequently, it is computationally harder for an adversary to invert a transformed template to its original form, even if the user's key is compromised. The key issues of a template transformation technique are the selection of transformation function that conserved the discriminability of template or query data and maintained the secrecy of user-specific key utilized in the transformation process. Practically, it is harder to design a transformation function that meets both the requirements of discriminability and non-invertibility simultaneously. Now let us talk about biometric crypto system. The figure represents schematic diagram of biometric cryptosystem technique used for template protection in biometric security systems. In the recent past, researchers have drawn their attention on the fusion of two most latent technologies, that is biometric and cryptography, in terms of security. Biometrics is a security technology used to authenticate individuals using their body mark with a high degree of assurance, while cryptography is used to assure the secrecy and authenticity of information in the communication channel. A fusion of biometric and cryptography is referred as biometric cryptosystem. The key advantage of using biometric cryptosystem is that it stores the digital signature of an individual in the database instead of storing the original biometric template. Therefore, it creates anonymous database that eliminates the security and privacy concerns of the user. The critical issue of biometric cryptosystem is the evolvement of an optimal encryption technique that is being capable to handle the intra-individual variability of the biometric data. That is, we have to devise the error-tolerant encryption technique for the implementation of biometric cryptosystem for robust identity verification. The performance of template protection techniques such as template transformation and biometric cryptosystem associated to different biometrics are shown in below tables. The performance of template protection technique is estimated on different datasets and different test conditions. Analyzing the advantages and disadvantages of each methods, it can be observed that the success of the cited template protection technique have been limited due to conditions imposed by many real applications. This is because the modified template based on the existing schemes increases the authentication error rate and demands more computation during matching, which is further compounded by the lack of standards for defining and storing modified templates. All of the presented techniques have just emerged, and it is obvious that time is required until these techniques are truly applied. As the use of biometric based authentication became more popular, the security issue probably represents the most important concern that has to be addressed during the design of a biometric authentication system. Biometric systems are vulnerable against a number of threats. We have classified the threats of a biometric system as faults, failures, and security attacks. To guard against vulnerabilities, the defense techniques such as vitality detection and biometric templates protection are critically reviewed. In particular, a classification of current state-of-the-art of vitality detection techniques of commonly used biometrics, that is face, fingerprint, and iris, is given. We have critically reviewed the vitality detection technique and evaluated their performance on the datasets and the test conditions used for the experiment. A template protection technique with provable security and acceptable recognition performance remains to be puzzled. The commonly used template protection techniques proposed in the literature, such as biometric template transformation and biometric cryptosystems, are discussed. The performance of these techniques are estimated on the datasets and the test conditions used in the experiment. We believe that the available template protection techniques are not yet sufficiently matured for large-scale applications.